Good evening, students. Today we are going to start with a new topic, semiconductor electronics. Okay, so here we are defining the new type of the material, that is the semiconductors. Already we have discussed about the conductors and the insulators. Yes, so can anyone define what do you mean by the conductor? So three types of material. One is conductor, then insulator, or you can also call it as a bad conductor. Then we have the semiconductors. Okay, so we can divide the materials into three types: conductors, semiconductors, insulators. Okay, so what do you mean by conductor here? Conductor is nothing but what? These are the materials which allow the electricity to pass through them. They are called as conductors. Okay, so here the conductors, the example for the conductors, we can take all the metals are the example for the conductors, right? So conductors are those which are having the free electrons which is available for the conduction of the electricity. Those are called as the conductors. Then next, insulators. So insulators, or you can also call it as what? Bad conductor. So in case of the bad conductor or the insulators, here it will not allow the electricity to pass through them at any condition. Those are called as the insulators. So here, as the name indicates, semiconductor. So what do you mean by the semiconductor? Semiconductor means that is, so here semi means here you can say it like it is half. Okay, so what is that? That is here the materials which are showing in between properties of the conductors and the insulators. Those type of materials are called as what? Semiconductors. So here what I said, that is, it is behaving in between these two properties, conductors and insulators. So how we can explain that? At room temperature. So here at room temperature, the materials are behaving as a insulator. So semiconductor ಅನ್ನುವಂತ material ಏನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ at room temperature it is behaving as a insulator. Okay, so when you increase the temperature, when the temperature is increased, it will start behaving like a conductor. Getting my point? So here what is semiconductor? You can define the semiconductors as it is having the conductivity in between the metals and the insulators. So in between the metals and the insulator, in the sense at room temperature it is behaving as insulator, and at if you increase the temperature it will start behaving like a conductor. Okay, so those are called as what? Semiconductors. So again, in the semiconductors we have different types, but before that, here let us see some of the points. So else the possesses very low resistivity and high conductivity. So regarding metals, semiconductors, we have some points here. You can note down those points. So here for the metals, they possess very low resistivity or high conductivity. Here the resistivity is of the order of, for the metals, the resistivity is of the order of 10 raised to minus 2 ohm meter and 10 raised to minus 8 ohm meter. This is the resistivity for the metals. And for the semiconductors, and the conductivity value is, it is 10 to the power of 2 to 10 to the power of 8. That is the conductivity value for the metals. Now you can see for the semiconductors. So see, for the semiconductors, they have resistivity or conductivity intermediate to metals and insulators. So the semiconductors are having the in-between properties of the metals and the insulators. Okay, so here the resistivity value is between 10 to the power of minus 5 to 10 to the power of 6 ohm meter. This is the resistivity, and the conductivity value is 10 to the power of 5 to the 10 to the power of minus 6 Simon per meter. Yes, so now you can see the different types of the semiconductors. So here the semiconductors, basically we can define it or divide it into three types. That is the elemental semiconductor, compound semiconductors, and one more is there, that is called as the organic semiconductor. Okay, so for our study we have only elemental semiconductors and the compound semiconductors. So what is elemental semiconductors? So these semiconductors are available in the natural form. So whatever the natural form or the naturally existing semiconductors are there, those are called as what? Elemental semiconductors. Those are called as elemental semiconductors. Okay. So here what we have discussed here, students, the materials can be divided into three types, that is metals, semiconductors and insulators. And again the semiconductors we are dividing into three types actually, but here we have only two. One is the elemental semiconductor and one more is the compound semiconductor. Okay. So in case of the elemental semiconductor, in the sense, the naturally existing semiconductors are called as what? Elemental semiconductors. So in case of the elemental semiconductors, we have only germanium and silicon. We have only, so if you see the periodic table, in the full periodic table, total how many elements are there, students? Yes, how many elements are there in the periodic table? 118, right? So total we have 118 elements. In the 118 elements, we have only two elements which are behaving as the, that is elemental semiconductor or the semiconductors. So the two semiconductors are, one is silicon. So one is silicon and one more is, that is germanium. So silicon and the germanium. These are the elemental semiconductors. Okay. Hope so you are understanding. Elemental semiconductors are the naturally existing semiconductors. So in the periodic table, we have only two naturally existing semiconductors, that is germanium and the silicon. Can anyone tell me what is the atomic number of the germanium and the silicon? Yes, what is the atomic number for the germanium and the silicon? Atomic number for the silicon, yes, it is 14, right? For the silicon, it is 14. Germanium 32. Okay, remember this because it will help us for further studies here. So here the silicon is having the atomic number as 14 and the germanium is having the atomic number as 32, right? Next. Okay, very good. So next we have the second type, that is the compound semiconductors, students. So what is compound semiconductors? These are the semiconductors by compounding the metals. So here what happens, that is two or more metals are combined here, which will form the compound semiconductors. So in that we have the cadmium sulfide, gallium arsenic, cadmium arsenide, and we have indium phosphate, right? So anthracene, polyline, these are also the example for the compound semiconductors. So in the elemental semiconductors, we have only two, but in the compound semiconductors, we have many examples. The next one, that is the insulators. So they have high resistivity or low conductivity. Those are called as what? Insulators. Okay, so we have completed the three types of the materials, that is metals, semiconductors and the insulators. So the difference between the metals and the insulator is, these are having the low resistivity power and insulators are having the high resistivity power. And in case of metals, we have high conductivity, and in case of this insulators, we have low conductivity. Okay. Next. So next we have the definition of the energy band. Then we have valence band, conduction band, energy gap. So these are the basic definitions to continue with the studies in this chapter. So first point or the first definition we are discussing, that is energy band. Okay. So see what is energy band here. In a crystal, due to interatomic interactions. So as you know that here, whatever we are discussing, it is regarding with the metals. So ನೀವು ಏನ್ imagine ಮಾಡಬೇಕು, you are discussing about the metals ಅಂತ ನೀವು ಇಲ್ಲಿ imagine ಮಾಡಬೇಕಾಗುತ್ತೆ. So in case of those metals, whatever the crystal arrangement is there, here in between the atoms, there will be a force, right? So interatomic forces will be there. intermolecular forces you can call them. So intermolecular forces will be there. Due to that, here the valence electrons of the atom are shared by more than one atom in the crystal. So suppose if you take the crystal structure of any of the metal here, so one metal is sharing the bond with the many metals, many atoms in its surrounding. It is sharing many at bondings with the neighboring atoms, we can say, in the crystal. Okay. Now splitting up of the energy level takes place, and the collection of these closely spaced energy levels are called energy band. So here whatever the energy band is there, that is the group of energy levels in the metals. So ಇಲ್ಲೇನಾಗತ್ತೆ ಅಂತ ಅಂದ್ರೆ here the interatomic forces will be there, intermolecular forces will be there between the atoms. Okay. So due to this, the different energy levels are formed. Due to this, the different energy levels are formed. So whatever the different energy levels are formed, those are giving you what? Energy bands. Those are giving us the energy bands. Clear? So this is regarding the energy bands here. So how you can define the energy band? We can define the energy band as what? It is the group of energy level with continuous energy variation. We can define it as what? That is group of, we can define in short, that is the group of energy levels, group of energy levels with continuous energy variation. With continuous energy variation is giving you the energy band here. Okay. So next we are discussing about the valence band and the conduction band. So ಈಗ ಏನಾಗಿದೆ, that is we have the energy band. Okay. So in the energy band, next what we are seeing, see. So in this energy band we have the valence band. So what do you mean by the valence band here? Valence band is nothing but these are the energy band which includes the valence electron. So if you consider the metals, okay, so when we consider the metals, here the metals are containing the free electrons in its outermost orbit. Okay. So here we have the free electrons in its outermost orbit. So whatever the outermost orbit electrons are there, those electrons are called as what? Valence electrons. Those are called as what? Valence electrons. Those are called as valence electrons. Okay. So due to these valence electrons, whatever the energy band we are getting, though that energy band is called as what? That is valence band. So that energy band is called as valence band. Okay. Next is, that is the conduction band. Okay. So next is conduction band in the energy band above the valency band. So when we consider the energy level diagram here, so with respect to any one metal here, students, when we consider the energy band, so here we have the lower band as what? Valency band. The lower band as that valency band, and here we have the conduction band. Here we have the conduction band. So that is the conduction band is the energy band above the valency band. Yes. So this entire structure ಏನ್ ಹೇಳ್ತೀರಾ? Energy band ಅಂತ ಹೇಳ್ತೀರಾ. Valence electrons ಇರೋ band ಗೆ valency band ಅಂತ ಹೇಳ್ತಾರೆ. And above that we have the conduction band. ಅಥವಾ ನೀವು ಮತ್ತೊಂದು ರೀತಿಯಾಗಿ ಏನ್ ಡಿಫೈನ್ ಮಾಡಬಹುದು ಅಂತಂದ್ರೆ, where we have the conduction electrons, those are called as what? Conduction band. Okay. So you can also say the free electrons will occupy here. The band is called as what? Conduction band. So valency band, conduction band. So now you can see whatever the energy means valence band and conduction band is there. Here in between we have a gap, right? So they are not overlapping here. So in between that we have some slight gap here. So that gap is called as what? That is energy gap. That gap is called as what? Energy gap. Okay. Yes. See, any doubt is there in any of the definition? Any doubt is there, students? Metal, semiconductors, insulators, types of semiconductors. Then in the semiconductors, we have discussed some of the definitions. See. Okay. Yes. Let us go for the next point now. Okay. The next one. That is Fermi energy. See, what is Fermi energy? It is the maximum possible energy possessed by free electrons of a material at absolute zero temperature. That energy is called as what? Fermi energy. So what is Fermi energy here, students? Fermi energy is nothing but it is the maximum possible energy possessed by the free electrons of a material at absolute zero temperature. So at zero temperature, in free electrons irutte, valence electrons, whatever the energy it will gain, that energy is called as what? Fermi energy. Okay. So on the basis of the purity, we can divide the semiconductors again. Yes. So here we have many definitions only. So it is maximum theoretical chapter. Okay. So maximum we have the definitions. Yes. So these are just definitions. You may not get it in the exam, but you should know before going to understand the further points. Okay. So see. Next, what we are defining, that is intrinsic semiconductors and the extrinsic semiconductors. So see, what is intrinsic semiconductor? Yes. So intrinsic semiconductors. So intrinsic semiconductors are nothing but these are the pure conductors without any dopants. ಅಥವಾ ನೀವೇನ ಅಲ್ಲಿ first ನೀವೇನ್ define ಮಾಡಿದ್ರಿ elemental semiconductors ಅಂತ. Those elemental semiconductors itself, it is called as what? Intrinsic semiconductor. Those are called as what? Intrinsic semiconductors. Okay. So what is intrinsic semiconductors? The pure semiconductors are called as the intrinsic semiconductors. So we have only two examples, that is germanium and the silicon. So silicon and germanium are the example for the intrinsic semiconductors. Yes. See. Okay. Next, we have the extrinsic semiconductor. Okay. So here the question comes, when we have the intrinsic semiconductors, ಮತ್ತ್ಯಾಕೆ ಇಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಹೌದಾ. ಸೊ ಯಾಕೆ ನಾವ್ ಇಲ್ಲಿ ಡಿವೈಡ್ ಮಾಡ್ತಾ ಇದೀವಿ ಸ್ಟೂಡೆಂಟ್ಸ್? ಬಿಕಾಸ್ ನ್ಯಾಚುರಲಿ ಎಕ್ಸಿಸ್ಟಿಂಗ್ ಇನ್ ಸಿಲಿಕಾನ್ ಮತ್ತೆ ಜರ್ಮೇನಿಯಂ ಇದೆ ಅಂದ್ರೆ ಇಂಟ್ರಿನ್ಸಿಕ್ ಸೆಮಿಕಂಡಕ್ಟರ್, or you can say it as a pure semiconductor. These semiconductors are of practical uses. Okay, so practical uses, these are not that much suitable. So for that reason, we have the extrinsic semiconductors. So extrinsic semiconductors ಅಲ್ಲಿ ನಾವ್ ಏನ್ ಮಾಡ್ತೀವಿ ಅಂತ ಅಂದ್ರೆ, in case of the extrinsic semiconductors, so in case of the extrinsic semiconductors, here we are adding some impurities. So here, suppose here we have the silicon crystal. So for this silicon crystal, what we are doing, we are adding here, we are adding in this some impurities. We are adding some impurities. So this process is called as what? So the adding process. ಅಂದ್ರೆ ಇಲ್ಲಿ ನೀವು impurities add ಮಾಡ್ತಾ ಇದ್ದೀರಾ. The adding of the impurities to the metals, this process is called as what? That is doping. ಈ process ಅನ್ನ ಏನಂತ ಹೇಳ್ತಾರೆ? It is called as the doping. And whatever the impurities you are using. Okay, so for example, if you are preparing, that is tea. So when you are preparing tea, whatever you are adding the ingredients here, whatever the ingredients you are adding, so the ingredients are called as what? That is dopant. Okay, those ingredients are called as what? Dopant. And here the process of adding those ingredients into the tea, boiling tea, this is called as what? Doping process. Understanding? So what is doping? What is dopant here? The process is called as doping, and what you are adding the impurities, those are called as what? Dopant. So dopant and the doping. Yes. So by this doping and dopant, what you are getting the semiconductors, those semiconductors are called as what? Extrinsic semiconductors. Is it clear, students? What is intrinsic semiconductors? What is extrinsic semiconductors? So intrinsic semiconductors are nothing but what? These are the pure semiconductors. Okay, so that is the naturally existing. Only two examples we have, that is the germanium and the silicon. In case of the extrinsic semiconductors, we are adding for this intrinsic semiconductors, we are adding the impurities and we are getting the semiconductors. Those are called as the extrinsic semiconductors. Yes. Yes, extrinsic semiconductors. So here we need to define in case of the extrinsic semiconductors three terms. One is what is extrinsic semiconductor, and the second one is doping and dopant. Okay, so extrinsic semiconductors, by this only you are getting. When you are adding the doping or the dopant materials, the process is called as the doping. By doping, what you are getting? By doping, you are getting the extrinsic semiconductors. Yes. Okay. Now, so after understanding the types of the semiconductors based on their purity, now we are going to define the extrinsic semiconductors. Again, in extrinsic semiconductors, we have two types. So what are the two types of the extrinsic semiconductors? That is based on the impurities. Means here which type of impurities you are adding to this semiconductors. We are dividing it into two types. One is N-type semiconductor and one is the P-type semiconductors. Okay. So I'll repeat here, students. That is, we are dividing the semiconductors based on the purity, two types. One is intrinsic semiconductor and one more is the extrinsic semiconductor. Intrinsic semiconductors are elemental semiconductors itself. Extrinsic semiconductors, by adding impurities to the intrinsic semiconductors, you are getting extrinsic semiconductors. And based on the impurities what you are adding, the extrinsic semiconductors are divided into two types. One is the N-type semiconductor and one more is the P-type of semiconductors. Okay. So now see how we are getting N-type and the P-type. So this is very, very important point, because based on this, you will get 2 marks question, write the difference between the N-type and the P-type semiconductors. Okay, so concentrate here. In case of the N-type of the semiconductors, here we can make some points. In case of the N-type of semiconductors, the majority charge carriers are electrons. So in the extrinsic semiconductors, we are having the majority charge carriers and the minority charge carriers. In this N-type, the majority charge carriers are electrons, and the minority charge carriers are holes. The minority charge carriers are holes. Okay. So when we can get this type of semiconductors, when we are adding the pentavalent. So when we are adding the pentavalent to the intrinsic semiconductors, we are getting N type of semiconductors. Okay, so what is pentavalent here, students? So pentavalent in the sense, in the valence electrons, there will be 5 electrons. Okay. So whatever silicon and germanium you have seen, in case of the silicon, it is tetravalent. Silicon hai to germanium hai to, here these are having tetravalent. So tetra in the sense, in the outermost orbit, we have the 4 electrons. We have the 4 electrons. See. Okay, so this is the tetravalent. So now to get the N type of semiconductor, what we are doing for silicon or germanium, we are adding the pentavalent. Okay, so what happens when you add the pentavalent? See, so this is our silicon. Here we have one atom. This is tetravalent, as I told you. So now when I add the pentavalent, for this, when I add the pentavalent, so pentavalent in the sense the 5 electrons will be there. Here one electron will come, here one electron will come, here one, and here one. So total 5 are there. Here I have given 4 and one more is left out. Yes. So whatever the pentavalent you have added here, this will form a covalent bond with the silicon. This is forming the covalent bond with the silicon atom here. Yes. So now one is left out. So this is nothing but the one free electron we have, right? So in if you consider the silicon is not containing silicon here. What neighboring atoms. Yes. So when we are adding the impurity to this, with respect to one atom, we are getting one electron. With respect to second atom, we are getting the second electron. Like this, we are getting one number of electrons. Okay. So which will allow or which is helping us for the flow of electricity. Yes. So how you define the electric current? Electric current is nothing but what? The rate of flow of free electrons is called as what? That is electricity, right? So in case of the N type of semiconductors, here what happens, that is the pentavalent what you are adding, from that we are getting one extra electron. From that we are getting the extra electron. So that extra electron will help us for the flow of the electricity. Yes. If any doubt is there, you can ask here. So here you need to remember, to get the that is N type of semiconductor, we are adding the pentavalent. Second point, here the number of electrons will be greater or more than the number of holes. And the pentavalent, whatever the elements you are adding, those are containing, means the example for the pentavalent, arsenic is there, aluminium and all, it is trivalent. Yes. See, N type, is it clear? So if you understand N type, P type will be easy for you. Six to 7 marks you can get from this chapter. Okay, so one we can get it in 5 marks, and then next in MCQs one in 2 marks. It may come, may not come. So total 6 to 7 marks we can expect from the semiconductors. Yes. So N type of semiconductors. Now see the comparison when you do, you can understand in a better way. Now in case of the P type of semiconductors, students. So in case of the P type of semiconductors, here we are adding the trivalent. Okay. So there we are adding the pentavalent, and here we are adding the trivalent elements. And the next here it is reverse. In that case we have the more number of electrons. Here we have more number of holes will be there compared to the electrons. The number of holes will be more than the number of electrons. The third point regarding the p-type semiconductor is, here what happens, so when you are adding it for the silicon is having the tetravalent, four electrons will be there. So when you are adding the trivalent, here it will form bond with only three atoms, right? So only three covalent bond is there, one is left out here, so therefore the one vacant place we are getting here. So whatever the vacant place you are getting here, this vacant place they will call it as what, that is holes. Okay, so holes we assume it as what, that is the positive charge carriers. So electronic ಯಾವ ತರ negative charge carriers ಅಂತ ಹೇಳ್ತೀರಾ, the holes can be called as what, positive charge carriers. Yes. So ಹಾಗಾದ್ರೆ what are the example for the trivalent elements here? The trivalent, we can consider the aluminum is there, indium is there. Yes. So this is regarding the pentavalent and the p-type and the n-type of semiconductors. Extrinsic semiconductors, we have the two types here. Now, for this at equilibrium condition, so for the equilibrium condition, we have one formula, Ne, the product of Ne and the NH, the product of the number of electrons to the number of holes will give you, that is the electron concentration. Okay, so the concentration of the ions can be calculated by using this formula. So at the end of the lesson, we will see some numericals on this formula. So at equilibrium condition, it is Ne into NH is equal to Ni square. Ne is number of electrons, NH is number of holes, Ni is, that is